Have you ever wondered how steel is made? It's a question that's rarely asked, yet the answer is embedded in the world around us. Steel, a cornerstone of our modern civilization, is in our buildings, our vehicles, our appliances, and even in our tools. It all starts with a process that's as fascinating as it is complex. The birth of steel begins deep within the earth, where iron ore, the primary raw material, is extracted. This mineral-rich substance is the first step in a journey that transforms it into the steel we see and use every day. From the tallest skyscrapers to the smallest screw, steel is a testament to human ingenuity and our ability to harness the natural resources of our planet. Understanding the creation of steel provides a new perspective on the world around us, illuminating the intricate processes that shape our everyday existence. So, the journey of creating steel begins with the extraction of its raw material, iron ore. Iron ore, an abundant element on Earth, serves as the primary raw material for steel production. This humble rock, rich in iron and other minerals, is the starting point of a journey that culminates in the creation of steel, a material that shapes the world around us. The extraction of iron ore is a story of human ingenuity. Miners delve deep into the earth, their heavy machinery cutting through layers of rock and dirt to reach the precious resource. It's a tough job, but the reward is a treasure of iron ore, ready to be processed and transformed. Once the iron ore is extracted, it's not ready for use just yet. It needs to go through a process of crushing and sorting. The ore is broken down into smaller pieces, making it easier to handle and more efficient to process. It's then sorted, with the iron-rich fragments separated from the less valuable material. What we're left with is a concentrated form of iron ore, packed full of potential. And now, the magic begins. The iron ore is loaded into a blast furnace, a towering structure that reaches temperatures hot enough to melt iron. Inside this fiery behemoth, the iron ore is subjected to a chemical reaction with coke, a form of carbon, and limestone. This process reduces the iron ore into molten iron, a sight that's as awe-inspiring as it is crucial to steel production. This molten iron, glowing with intense heat, is then poured into molds where it cools and solidifies. The result is pig iron, a crude form of iron that's ready to be refined further into steel. It's a testament to the power of heat and pressure, transforming a simple rock into a valuable resource. And there you have it. From the depths of the earth to the intense heat of the blast furnace, we've followed the journey of iron ore as it becomes iron. It's a transformative process, a testament to human innovation and the incredible properties of the natural world. With iron now in hand, we are one step closer to creating steel. The journey from iron to steel is a fascinating one. Now that we have our raw iron from the previous process, it's time to transform this elemental metal into something more robust and versatile: steel. The magic of this transformation lies in the addition of one key ingredient: carbon. You see, iron on its own is a fairly soft metal. By introducing carbon into the mix, we can significantly increase the hardness and strength of the resulting steel. So, how exactly is this done? Well, the process takes place in a massive structure known as the basic oxygen furnace. This towering behemoth heats our raw iron to incredibly high temperatures, making it molten and more receptive to the carbon we're about to introduce. As the name suggests, the basic oxygen furnace also pumps in oxygen. This oxygen reacts with the impurities in the iron, creating a layer of slag that we can easily remove. With these impurities gone, we're left with a cleaner base for our steel. Once we have our molten, purified iron, it's time to add the carbon. This is done by introducing carbon-rich materials into the mix. The precise amount of carbon added will dictate the characteristics of the resulting steel. For instance, if we add a small amount of carbon, we'll end up with low-carbon steel, which is relatively soft and easily worked. If we add a bit more carbon, we get medium-carbon steel, which is harder and stronger. And if we really ramp up the carbon content, we end up with high-carbon steel, which is incredibly hard and strong, but also more brittle. So in essence, the creation of steel is a carefully controlled chemical reaction. By manipulating the amounts of iron, carbon, and other elements in the mix, we can create a huge range of steel types, each with their own unique properties. And there you have it. With the help of a basic oxygen furnace and a dash of carbon, we have transformed our raw iron into various types of steel. This process gives us the robust and versatile material we know as steel. Now that we have our steel, it's time to shape it. Shaping steel is an art in itself, a transformative process that turns our raw material into something more tangible, more usable. We're talking sheets, rods, bars, and coils. And how do we achieve this? Through a process known as rolling. Imagine a giant rolling pin, but for steel. This is exactly what a rolling mill does. But unlike your kitchen rolling pin, these mills apply a massive amount of pressure to the steel, forcing it into the desired shape. There are two types of rolling processes, hot and cold. Let's start with hot rolling. As the name suggests, the steel is heated until it's scorching hot, making it more pliable and easier to shape. This is usually the first step in the shaping process, helping to break down the steel's structure and give it a rough form. But hot rolling alone isn't enough. The steel is still too malleable, too soft for practical use. That's where cold rolling comes in. The steel is cooled down and then rolled again. This process refines the shape and, more importantly, hardens the steel, giving it the strength we associate with this incredible material. Speaking of cooling, it's a crucial part of the shaping process. After the steel has been rolled, it needs to be cooled down slowly and uniformly. This allows the steel to harden properly and prevents any internal stresses that could weaken it. Think of it as a kind of relaxation period for the steel, a moment to settle into its new form. Of course, the exact processes and temperatures used can vary depending on the type of steel and the desired end product. But regardless of these variations, the principles remain the same: heat, roll, cool, and harden. So through the magic of rolling, heating, and cooling, our steel takes shape, transforming from a rough, raw material into a versatile and vital component of our everyday lives. With the steel shaped, we're almost at the end of our journey. The final touches are what makes steel a versatile material. Yes, that's right. After the shaping, the steel is not yet ready to conquer the world. There's another crucial step that gives steel its finished properties and makes it suitable for a wide range of uses. This step is none other than the finishing processes, which includes coating and galvanizing. Coating is a process where a layer of another material is applied to the surface of the steel. This layer serves as a protective barrier, shielding the steel from the elements and preventing corrosion. There are different types of coatings for different purposes. For instance, a polymer coating can increase the steel's resistance to chemicals, while a metallic coating can improve its electrical conductivity. The type of coating used largely depends on what the steel will be used for. On the other hand, galvanizing is a specific type of coating where a layer of zinc is applied to the steel. This process is particularly useful for outdoor applications, as it provides excellent resistance to weathering and corrosion. The zinc acts as a sacrificial anode, corroding in place of the steel and prolonging its lifespan. These finishing processes are not just about protection, though. They can also enhance the steel's aesthetics, providing a shiny, smooth finish that is pleasing to the eye. Plus, they can add functional properties like anti-fingerprint or anti-graffiti features, which can be particularly useful in public spaces. And the beauty of it all? The steel can be finished in a multitude of ways, depending on its intended use. It can be coated or galvanized for construction purposes, painted for automotive applications, or polished for decorative items. This versatility is what makes steel such a widely used material. So after the birth of steel, its transformation from iron ore to iron, the creation of steel itself, the shaping, and finally the finishing touches, the steel is ready. And with that, the steel is ready to be used in numerous applications around the world. It's a fascinating journey, isn't it? And it all starts with a simple piece of iron ore. The journey of steel production is a complex yet fascinating one. We've ventured from the birth of steel, beginning with the extraction of iron ore, a fundamental component in the creation of this sturdy material. We've seen how iron ore is transformed into iron, a process that involves heating and chemical reactions. Then we delved into the creation of steel itself, an alloy of iron and carbon, where the amount of carbon is meticulously controlled to achieve the desired properties. Shaping the steel, we've learned, is an art in itself, involving heat and force to mold it into the many shapes and forms we see in our daily lives. The final touches, such as tempering, polishing, and coating, are what give the steel its finished look and additional properties, like rust resistance. Each step in this journey is vital, and none can be skipped. Next time you see a steel product, you'll know the remarkable journey it took to get there.